All right, welcome back, you guys. All right, so we're on our last activity with the gizmo. I've already clicked clear as it told me in my box, and then it said use the gizmo to create two parents with these genotypes. So I'm going to go ahead and do that really quick so I have it out of the way. Remember, if you haven't figured out how to do this yet, you might have to play around, but you should be able to start figuring out how these genotypes come together to find those two. Okay, so I've got the gizmo to create the parents. I'm going to put them in my boxes and then I'm going to keep reading for directions. Okay, because this first part is going to have me kind of pause on the gizmo. So in activity B, we learned how to do two Punnett squares and then multiply the probabilities from those Punnett squares to find out probability for two traits. Okay, well, now we're actually going to be looking at a dihybrid cross, which is a little more difficult, but it's how we look at two traits in one Punnett square. It's just a much larger one, as you can see. So we call it the 4x4 Punnett square. So in our model, we have these two parents, and they have alleles for fur color and eye color. So here are our parent genotypes. It says there's 4 possible allele combinations the parent could pass on to its offspring, and they list them for you right here. You guys can see how that works out, right? If we have two parents, they can each donate these alleles to their offspring, okay? So we've taken the possibilities and we've inputted them for you on the Punnett square for the first parent and the second parent, okay? And then we started filling in the Punnett square for you. Then your job is to continue filling out the Punnett square. You're doing it the same way that you would any other Punnett square by dropping down, carrying over, and filling in the box based on the alleles that you see. So make sure that you fill this in before you move on. And then it's going to ask you to express each probability as a fraction and a percentage below. So for these 4 options here, you're going to give us the fraction and or percentage. Remember, fraction is part over whole. So now that we have a 4x4 square, this is going to be out of 16 rather than just your typical Punnett square used to be out of 4. So make sure that you change and adjust for that. And then you might need some help on the percentages. And remember, you can do that by just taking the fraction in a calculator and multiplying times 100 to get a percent. Okay, so make sure you get that done. And be careful of what alleles you're looking at based on these phenotypes that it's asking you for. Okay, now it gets us down to the gizmo. It says click show statistics. I always have these turned on. Be sure that there's 2 parents with those genotypes given, capital F, lowercase f, capital E, lowercase e. Click breed till there's 500 offsprings and write the results in the table. So I'm just going to click breed a couple of times. Make sure your number here says 500 and then start filling in what you see. So right now I have show as approximate percentage. So these are the numbers I would record in the bottom half of the table. If I uncheck that box, it tells me how many mice there are that fit those phenotypes, and that's what I would put in this number part of my table. Okay, so this is really just plugging and chugging into the data table, and then you need to answer the analysis question. How did the results from the gizmo, so what we just did here, these numbers that you recorded in the data table, how did those numbers match up with the predictions from your Punnett square right here? So you have the percentages right here to look at based on the phenotype. So you're comparing these percentages with these percentages, and then you're making your observation for your analysis. And that's it for part C.